So now we are at this stage where we have created the environment and we have added some obstacles. So now is the time to add a robot. So in order to do that, we are going to click on the last wooden box, and we are going to click again on the add new object or import an object, and you're going to basically see the same window as before. So we can click on proto-nodes, and then we can go to robots. And here, if you inspect the different robots, you will find like a portal robot. You will find like an ABB, RB robot, which is a kind of like very common industrial robot. You will also find like a few from Boston Dynamics, like very fancy advanced robots. KUKA, which is one of the most common, makers of industrial robots. I don't know, Universal Robot, which is one of the ones we were showing before, which is one of the most common robot arms. But in our case, we are going to be interested into adding like a pack robot. So you can go to GCtronic, you can click on epack, you can select this one, and you can click add. And you will see now that the robot appears like right at the center. So we are going to save our wall. And now if you click play, you are going to see that the robot is moving around. And this is because when we put the robot, it already comes preloaded with a controller. Remember, the controller is the programming code that defines robot functionality. So it already came preloaded with one. And if we expand the epack, we can go to the controller entry, and you can see that it says epack avoid obstacles. So it already came with some code, which is basically going to move the robot around avoiding obstacles. And here, for example, if you click edit, you can see the code, which is a bit complex, so don't worry about that. We are not going to do anything with this code. But just so you have an idea that the robot already came with something, and that's why it already has some behavior. So I'm going to pause it. No, I'm going to let it run. And remember, if you click like Alt and left click, we are applying a force. So this is another good example to try this. So yeah, you can see how I'm moving the robot around. I'm going to pause it, and then I'm going to just go to the beginning, and I'm going to do the next thing that the tutorial recommends, which is changing the basic step. So I'm going to go to the scene tree, and I'm going to go to world info, and here there is a lot of information like gravity, for example, 9.81 frames per second, and all these things. We are going to be interested in basic time step, and basic time step means in milliseconds how much time is going to take for the simulation to update and generate, a new simulation step. We are going to discuss this later on with more detail, but by default it's going to be 32, and the tutorial recommends to save it to 16. And basically the thing is that I didn't want to click this. Save, yeah. So the lower this number is, we are going to have like a higher resolution of simulation. So, it's going to be more realistic, but it's also going to use more computer power. So we need to be careful. Usually 32 is actually okay, depends on the example. Like if it's a robot like this one, moving around, 32 is probably okay. We don't want like something super detailed. But when robots are moving fast or something, you want to decrease this. So anyway, this is the end of the first part of the tutorial. You have created like a new world. You modified some of the basic characteristics like the tile size, and then you added some obstacles, and finally you added like a small robot which it's moving around and doing things. So yeah, this is the end of the first part. And the next part, what we are going to do is we are going to change the controller. So we are going to write our own controller for this robot so that we can define some specific functionality.